Now we will look at how the what does each and every point represents on the Laplace plane. Okay, so what is this complex variable? As it is nothing but sigma plus j omega. Okay, so sigma plus j omega. So since it is a complex variable, this is the real axis. Okay, sigma, and this is the j omega axis. Okay, now what does it mean to have a pole at minus 2? Okay, a pole at minus 2 means something like 1 divided by s plus 2. Okay, now you very well know that e to the power minus 2t in time domain has a Laplace transform of 1 divided by s plus 2. So it so in time domain it means this function. Okay, so this function in Laplace domain is represented by a single point at minus 2. Okay, this cross, so one cross here represents this entire function in time domain e to the power minus 2t. Now what about a cross at minus 4? So a cross at minus 4 means 1 divided by s plus 4. Okay, and you very well know that if you take inverse Laplace, okay, e to the power minus 4t will have a Laplace of 1 divided by s plus 4, which means you are having a pole at minus 4. So this 1 cross at minus 4 represents the entire e to the power minus 4t. And please also look at the two function. Okay, e to the power minus 2t, I have shown a slow decaying exponential. Okay, whereas e to the power minus 4t is a fast decaying exponential. Okay, so terms which are, so if you are having a pole which is far away from the j omega axis, then it will decay down very fast. Okay, and same thing applies on the other side also. If you are having a pole at plus 2, which means there in time domain it is e to the power 2t. Okay, e to the power 2t into u of t. Okay, if you take Laplace transform of e to the power 2t, it will be 1 over s minus 2, which is perfectly in accordance. Okay, because you are having a pole at plus 2. And please see that this function e to the power 2t, it does not have an upper bound. Okay, what does it mean? It means that as t tends to infinity, this e to the power 2t also tends to infinity. Okay, so it is unstable. What now? This e to the power minus 2t, as t tends to infinity, it goes to 0. Eh, it goes to 0. Okay, fine. So now what about this poles on the j omega axis? Please remember, if the poles are not lying on the x axis, that is the sigma axis, then they have to come in complex conjugate pair. So if there is a pole at plus 2j, okay, this is plus 2j. Okay, I have not written a j here, but it is assumed, because while plotting complex numbers you do not write a j here. Okay, it is assumed. So if there is a pole at plus 2j, then there is also a pole at minus 2j. Okay, and if you know, suppose there is a function sine t. Okay, sine t will have a Laplace transform of 1 divided by s square plus 1. So if s square plus 1 is equated to 0, then you have two imaginary poles. Then you have two imaginary roots, and these are exactly that. But in this case, the Laplace transform is 2 divided by s square plus 4. Okay, 2 divided by s square. So in time domain, this will be a sine wave, sine 2t. Okay, sine 2t is represented by these two cross over here. And please note that they have to come in complex conjugate pairs. Now what happens if the poles are not on the j omega axis but somewhere in the quadrants? Okay, if there is one pole here that is minus 3 plus 3j, then there has to be a complex conjugate which is minus 3 minus 3j, which is this. because they have to come in complex conjugate pairs. Now, what these two cross represents is a decaying exponential sinusoidal wave in time domain. Okay, and this envelope is e to the power minus 3t. Okay, this envelope is e to the power minus 3t, and the envelope dictates the amplitude of this sine 3t. Okay, please note that as t tends to infinity, anything in the left half plane, it decays down to 0. In contrast to anything in the right half plane, it explodes, that is, it goes to infinity. But what about values on the j omega axis? Well, values on j omega axis, if there are poles on j omega axis, they will they are known as something marginally stable. Okay, they are neither exploding to infinity nor they are decaying down to zero. They are sustaining themselves. Okay, so these are oscillatory functions as we call them. Okay, we have next slide here. So if there are two poles on the at the origin, okay, first let us see what a pole at origin means. Okay, if there is a pole at origin, which means it is 1 divided by s. So 1 divided by s, you very well know that u of t, that is 1, has a Laplace transform of 1 divided by s. So that 1 divided by s and s is equal to 0 means this point. So this point represents u of t. Okay. Now let us see when there are two poles on the origin. Okay. Two pole on the origin means 1 divided by s square, isn't it? And you can by intuition determine that t u of t has a Laplace transform of 1 divided by s square. Okay. Next thing. Okay, now what happens when there are two poles on the x-axis? Okay, what about if there are two poles on minus 4? So it is something like 1 divided by s plus 4 square, isn't it? So 1 divided by s plus 4 square is something like this. You know that if you multiply a function by t, then it is like differentiating in Laplace domain with respect to s and multiplying it by a negative sign. So we are doing minus d by ds Laplace transform of this quantity. So if you do minus d by ds 1 over s plus 4, it will give you 1 over s plus 4 square, which is this function. So this function is the Laplace transform of these two cross, and it is represented by this. Okay, somewhere on the time axis it will assume a maximum value, and then it will decay down to 0. As I told you, anything in the left half plane, it decays down to 0. Now let us see at this very interesting plot. Okay, there are two poles on minus 2 plus minus 3j. This has to be 3. Okay, this has to be minus 3. So minus 2 plus minus 3j, and there is a pole, there is a 0 at minus 2. If you look how this function, if you look, this is the function that we have plot. Okay, s plus 2 divided by s plus 2 square plus 3 square. If you do s plus 2 is equal to 0, then we have a 0 at minus 2, which is perfectly fine. And if you equate the denominator equal to 0, it is plus minus 3j. This has to be minus 3. Okay, there is a mistake, sorry. So there is a plus minus 3j and the real part is minus 2. Okay, so what it means is, if you take an inverse Laplace of this quantity, you already know from standard Laplace transforms that this function evaluates to e to the power minus 2t cos 3t. Okay, this is a cos, and why there is a cos coming? Because of this 0. Okay, s plus 2, this is a cos. Okay, without, okay, if there is not an exponential, then it will be s divided by s square plus 3 square. Okay, in which case the entire this x 0 and x would be lying on the j omega axis, in which case the exponential part would be e to the power 0 t, which is 1. Okay, similarly you have a rising cosine curve. Okay, whose amplitude is dictated by this rising exponential. Why it is a cosine curve? Because there is a cross, there is a 0, and there is a cross. Whereas in case of sine wave, there are only two crosses, right? Here and here. See, in case of sine wave, there this is a sine wave, isn't it? Because it is starting from 0. So here only one cross is there and only one cross is there.